We have been multiplying binomials for a little over a week at this point, and today we used this lesson, which is about special products of polynomials, in order to review multiplying with the algebra tiles and then also our FOIL method. So we used this as a platform to learn or to review a concept that you should already be familiar with. So the two types of special products that we talked about today are a sum and difference, which when we multiply those together, it makes something called the difference of two squares, and then the square of a binomial pattern, which is going to make a perfect square trinomial. Okay, so we started out by looking at our algebra tiles, and we noticed that whenever you do a sum and difference, so a sum and difference is when you have like x plus 2 and then x minus 2. So it's the same binomial, only one is addition and one is subtraction. And when you multiply a sum and difference together, what winds up happening is these two middle terms, the negative 2x and positive 2x in this case, are going to wind up canceling out, and then the two things that you're left with happen to be perfect squares. And that's why it's called the difference, because that's subtraction, of two squares. Okay, so here in this problem we had x minus 2 times x plus 2. So x times x was x squared. That's where this came from. Then x times negative 2 makes negative 2x. And then x times positive 2 made positive 2x. And then positive 2 times negative 2 made negative 4. So when I go to combine my like terms, which are my inners and outers right here, the positive 2x and negative 2x wind up canceling, and I'm left with x squared minus 4 as my simplified product. And that's going to happen every single time you do a sum and difference. Then we moved on and we talked about the square of a binomial pattern. Now at this point, I let you guys choose whether or not you wanted to use the algebra tiles or you wanted to do FOIL, and most of you chose FOIL. So the first thing we talked about is that when you have x plus 2 squared, that does not mean that you distribute the exponent inside of there. You cannot distribute exponents, or raise a power to a power over an addition or subtraction problem. So x plus 2 squared literally means that you have x plus 2 times itself, x plus 2. So once again, we did FOIL. We did first times first, so x times x is x squared. We did our last times our last, 2 times 2 is 4. My inners made 2x, and my outers made 2x. So when I went to combine my like terms, I had x squared plus 4x plus 4. And we talked about how with the square of a binomial pattern, that your middle terms are always going to be the same before you combine them. So I know I'm going to have 2x and 2x, which makes 4x. And it's happened over here too. We had the two negative 2x's and we got negative 4x. So what we're going to do now is we are going to do a couple of examples just to make sure that you're comfortable with FOIL and that you understand what's going on. Okay, so the first thing that we're looking at is our sum and difference. So hopefully you're already aware that that's going to make the difference of two squares. So we should be expecting our inners and outers to cancel. So we have x times x, that makes x squared. We have negative 4 times positive 4, that makes negative 16. There's my two perfect squares. My inners make negative 4x, and my outers make positive 4x. Just as I anticipated, my inners and outers are going to cancel, and I'm left with x squared minus 16, which is the difference of two squares. Okay? All right, let's look at one that has a coefficient. So I'm looking at letter C. If I do 3x times 3x, that's going to make 9x squared. 1 times negative 1 is going to make negative 1. There's my two perfect squares. Then my inners make positive 3x, and my outers make negative 3x. So once again, these cancel out, and I am left with 9x squared minus 1, which is the difference, because it's subtraction, of two squares. Now some of you at this point realize that if you know the pattern, that you can just square x, there's your x squared, and then square this term, that's 16, and then you know it's going to be subtraction. So let's see if that works over here. 3x squared would be 9x squared, because that's 3x times 3x. 1 squared is 1, and then I know it's a difference of 2 squares, so it is subtraction. Now, whether or not you can recognize that you could just use the pattern to create this, or whether or not you have to use FOIL, I do not have a preference. It will be helpful when we start factoring if you do recognize that this is going to make a sum and difference, or that a sum and difference makes the difference of 2 squares. All right, let's go ahead and look at the square of a binomial. The most made mistake when you're working with these is that people forget that it means x minus 2 times itself. Please, please, please do not just try to distribute or give that square to each piece. You need to use FOIL. X times x is x squared. Negative 2 times negative 2 is positive 4. My inners make negative 2x, and my outers make negative 2x. You've got to have your middle term. So if you were to just give the square to each piece, you would only get this top part, which is not correct. Now I'm going to go ahead and combine like terms. So I have x squared minus 4x plus 4. Remember, I'm getting minus 4x by adding those two things together. And then this would be my simplified product. All right, let's go ahead and look at the next one. Remember, that means 3x plus 1 times 3x plus 1. So I'm going to do 3x times 3x, which is 9x squared. 1 times 1 is 1. My inners make 3x, and my outers make 3x. And then I can combine like terms, which is going to leave me with 9x squared plus 6x plus 1. And that's going to be my simplified product. Now this pattern is a little bit more difficult to recognize, but what you should notice is that your first term of your product is this term squared, so 3x times 3x is 9x squared. Your last term is your last term squared, so 1 squared is 1. And then you know you're going to have your inners and outers are the same, and it's going to be 3x times 1 and then times 2, because there's 2 of them, which would give you 6x. Now, if you cannot recognize the pattern, that's okay. You can use FOIL to get your product. Okay, so if you have any questions about this or multiplying polynomials or binomials in general, please make sure you come in and get some extra help. You guys have a great day.